Hi guys, my butt hurts. So it sounds like a perfect time to do math. This is Standard Deviation Unit 5, Lesson 6, I think. I don't know, that's really little and I can't read. Standard deviation is a measure of variation whose calculation is based on the distance between each data value and the mean. Yeah, whatever. It can help us interpret how significant a data point is compared to the graph. Basically, this is a more complicated way of what we were doing in the last lesson, and I really don't know why they make it more complicated other than it's math, and math likes to be complicated. I mean, that's legit what I got from this. So how to calculate standard deviation? You do x minus, and I think with x over the line of it, I think it's the mean of x squared, means to take each data value x, subtract the mean, which is x with the bar over it, then square each result. And that little, I think that's sigma. No, it's probably not. Anyway, that little e means to add all of the values from step 1, and then you divide the result of step 2 by one fewer than the number of values in the data set, which is n minus 1. This is called the variance, the average squared distance between the data values and the mean of a data set. And the fourth step is to take the square root of the end result from step 3. So there's this formula that you can use, but honestly, these steps are how it teaches you to do it, and this makes way more sense to me than doing all of this garbage, especially because I don't understand all the like Greek symbols and everything, because I just don't care, okay? So here's example 1. Calculate the standard deviation of the following data set, round to the nearest hundredth. So it gives us a table that we're starting out with that has the value, and the total observations is how many times it occurs. So if we compare this back to our dot plots that we've been using, my dog is losing her mind. Okay, so how this would look as a dot plot is you'd have the values down here, and you'd have 1, 2, 3, 4, and 5, and then for each observance you'd have your dot, and for in this case each of these only has one dot, okay? But if this had like 2 or 3 or whatever, that's how many dots would come up here. I'll show you it again later. But this is just translating all of this information into dot plot form, which we're more familiar with. So to find the standard deviation, you need to find the mean of the data set. Okay, mean is the bully math where we have to add all of the values together and then divide by however many values we have. Okay, and then so let's do that first. Let's just find the mean. So we have, let me get a calculator because I don't try. 1 plus 2 plus 3 plus 4 plus 5 gives a 15 divided by, and how many dots do we have? We have 5. So our mean is going to be 3. Okay, mean is equal to 3. Sum the total value based on the observations in this data set. Each value has one observation, so that's what we did. We just found the mean. The mean is 3. Look at that. I'm a superstar. Wow. Okay. Next, find the difference between the mean and each data point. Okay. So this value x are each of the data points. These are each dot on our dot plot. Okay. And then we need to discover how far they are from the mean. So if we have 1 and our mean is 3, then 1 minus 3 is going to give us negative 2. So this time around, we're allowing negatives to happen on here. All right. So 2 minus 3 would be negative 1. 3 minus 3 would be 0. 3 minus 4. I'm sorry. 4 minus 3 would be 1. 5 minus 3 would be 2. So it's your x value minus our mean, okay, which is in the formula was x minus x with a bar over it. I'm sure there's a name for that, but that's the mean of x. That's the formula that we're doing, okay? So we filled in this table. Then we're going to take this difference. This is just this information that was right here, okay, and we moved it up. So we're going to take our difference from the mean and we're going to square each of those, because in that formula that we had x minus the mean of x, and then all of that was going to get squared. So we're just doing our next step. So 2 squared is 4, negative 2 squared, negative 1 squared is 1, 0 squared is 0, 1 squared is 1, 2 squared is 4. Okay, so this gets rid of these negative values in here. Before, we were just not letting there be negative values, okay? But now they're making it complicated. Now, because we squared it, okay, we need to add all of these squares together and divide by 1 less than the number of values in the data set. Again, they're making it more complicated. So we take that x minus the mean of x squared, and we're going to divide it by n minus 1. Okay? So we have 1, 2, 3, 4, 5 numbers. So that would end up being 5 minus 1. So we're going to divide everything by 4. Okay? So, oh my gosh, my dogs are losing their mind. So we're going to take the squared differences. So 4 plus 1 plus 0 plus 1 plus 4. Okay? Which is 10, and we're going to divide that by 5 minus 1, so 4. 10 divided by 4 gives us 2.5. Okay, 2.5 is going to be our variance. Okay, the variance of this data set is 2.5. That tells us where most of the data points are going to fall. They're going to fall within 2.5 points of our mean, which was 3. Okay, now because we squared all of this in the beginning, we have to deal with that because we screwed it up, right? So we have to take the square root of 2.5. That's not our final number because we messed everything up to get rid of the negatives. They're making it more complicated than it has to be, I swear. Okay, so we need to do 2.5 and the square root of it is 1.5811, blah, 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 blah. So it says round to the nearest hundredth, so it's going to be 1.58. Okay. Standard deviation is about 1.58. So as long as you get the steps in the right order, this is not difficult. Okay, thankfully. It's not like factoring. I hate factoring. Here's example number 2. Try to find the standard deviation of the following data set on your own before working through the worked example, round to the nearest hundredth. Okay, so if you didn't write down those steps, you can pause the video, go back, write down those steps. Right now, pause the video, try to solve this on your own, and then come back. If you can solve this on your own, then you can skip all of the next slides until we hit the practice and quick check questions, which look very different. They're a solid background. There's no pictures. Okay, so try to solve this on your own and then come back. So first we need to find the mean of the data set. So if this looks like our dot plot, what we're going to have is we're going to have the value 6, we're going to have the value 7, and we're going to have the value 8. Okay, and now we need to figure out how many dots there are. Let me make my dot bigger. Okay, so total observations, there's 1 dot at 6, there's 3 dots at 7, okay, and there's 1 dot at 8. You won't have to do this every time, but I'm a very visual person, so this is necessary for me. Just because it's necessary for me doesn't mean it's necessary for you. That means that when we're adding these together to find the mean, we're going to grab our calculator and we're going to go 6 plus 7 plus 7 plus 7, because there's 3 7s, plus 8. It gives us 35. And then we have 1, 2, 3, 4, 5 numbers. So 35 divided by 5 is going to give us a mean of 7. Okay, the mean equals 7. This is also in our formula. The x with a bar over it is equal to 7. Okay, the next step that we do is we need to find the difference between these data points and the mean. And this is written in the formula as big X minus x with a bar over it. Okay, and we're going to solve for each of these. So that means we have 6 minus 7 is going to give us a negative 1. 7 minus 7 is going to give us 0, 0, 0. 8 minus 7 is going to give us a positive 1. Okay, you can see that right here. The next thing that we need to do is find the difference between each mean and each data point. That we already did. I think that was the duplicate slide. Okay, now we need to square each of these to get rid of these negatives. Negative 1 times negative 1 is positive 1. These all stay 0, and positive 1 times positive 1 is positive 1. Okay, now we need to take all these, add them together, and divide by n minus 1. So we have 1 plus blah plus 1. So we have 2 over n. How many did we have? 1, 2, 3, 4, 5. 5 minus 1, which is going to end up being 2 divided by 4, which is going to give us 0.5 or 1/2, whichever way you want to look at it. Okay, then we need to find the square root of that. So we need to take the square root of 0.5. And that is definitely a calculator for me, dude. I don't do that. 0.5 square root is, and they want us to go to the hundredth. So it's 0.707. So it's going to be 0.7 1 for our final answer. The standard deviation is about 0.71. Okay, so if this is the answer that you got all on your own, you can go ahead and skip to the practice and quick check questions. Otherwise, stick with me for a minute. This is a check-in. Why are the squaring and square root steps of standard deviation important? So why are they making it complicated? Squaring and taking the square root allows you to work with only positive numbers, which we were doing before, but now they're being stinkers. You only work with positive numbers because you are describing the distance between the data point and the mean. You take the square root to undo the square you took to get the actual deviation. Again, because they're being bums. This is question number 1. This is all you. You should solve this on your own. It says calculate the standard deviation of the data set, round to the nearest hundredth. And my headset is going to die, so I'm going to have to stop there. Okay, go ahead and pause the video, come back, and we'll figure it out together. Don't cheat, don't be lazy, actually do the work. Okay, so the first thing we need to do is figure out the mean. So I'm going to make my little dot plot because that's what's easiest for me. We have 1, 2, 3, 4, and 5. Okay. And now we need to figure out how many times each one appears. So there's 1 dot for, oh my goodness, what happened? What happened? Oh, it didn't switch. Okay. 1 dot for 1, 1 dot for 2, 2 for 3, 1 and 1. Okay. So let's add all these together. Get my calculator, go 1 plus 2 plus 3 plus 3 plus 4 plus 5 gives us 18, and divide that by 1, 2, 3, 4, 5, 6. 18 divided by 6 gives us 3. So our mean is going to be 3, okay, equals 3. Now we need to get rid of all this garbage and make our next little chart, which is going to be our values, which is 1, 2, 3, 4, and oh wait, I have to have 2 3s. I forgot. Do I have to have 2 3s? Yes, I do. Okay, I have to have 2 3s. We have to have 3, 3, 4, 5, and we need to find the difference from the mean. So we take the numbers here and then we subtract the mean, and then we can find the next one. So we have 1 minus 3 is negative 2. 2 minus 3 is negative 1. 3 minus 3 is 0, 0. 4 minus 3 is 1. And 5 minus 3 is 2. Now the next step we need to do is square these so that we can get rid of all of the negatives. So negative 2 squared is 4. Negative 1 squared is 1. 0, 0. 1, 4. Now we need to find the mean of all of these. So 4 plus 1 is 5, 6, 7, 8, 9, 10. 10 divided by n minus 1. So we have 10 divided by n minus 1. 1, 2, 3, 4, 5, 6. 6 minus 1, so it ends up 10 divided by 5, which is 2. And then we need to take the square root of that. And the square root of 2 is calculator time. The square root of 2 is 1.414. And it wants the nearest hundredth, so it's going to be 1.41 for our standard deviation. Tonk, tonk. All right. Let's do question 2. Calculate the standard deviation of the graph round to the nearest hundredth. Use this information. Pause it, figure it out, come back. Okay, I'm going to see if I can handle it this time without drawing my dot plot. Watch me screw it up. It wouldn't surprise me. So the first thing to do is to figure out the mean. So I'm going to go 10, 11, 11, 11, 11, because it has 4 times that it's showing up, and then 12. This is going to be the beginning of our big table of information. Shonk, 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 shonk. And in our little formula, mean is represented by x with a line over the top. So let's figure that out. So we have 10 plus 11 plus 11 plus 11 plus 11 plus 12 gives us 66, divided by 1, 2, 3, 4, 5, 6. Divided by 6 gives us a mean of 11. Now we need to figure out the difference between the point and the mean, okay, which is part of the formula. So 10 minus 11 is negative 1. All of these are zeros because it's 11 minus 11, and 12 minus 11 is a positive 1. Now we need to get rid of, oops, all the negatives, so we need to square these numbers. Negative 1 times negative 1 becomes positive 1. These are all zeros, and this one also becomes positive 1. Now we need to find the mean again, so we need to do 1 plus 1, which is 2, divided by 1, 2, 3, 4, 5, 6. 2 divided by 6, yes, I'm using a calculator, is 0.33333333. So we'll go 0.33, because everything's going to the hundredth. Let's find the square root of that. Where's my square root button? There. It's 0.577, so we're going to say 0.58, and that's our final answer. So the steps are so simple that for me it's easier to not even bother with the written formula. If the written formula makes more sense for you, do that. If you just want to do the steps and the table, then, you know, whatever, however your brain works is totally fine. 0.63, look at me screwing it up. The mean is 11. I got the mean right. The variance is 0. Oh, that's because they did the square root of 0.4. This is why I hate this book. So if you take the square root of 0.4, which makes no sense because they're saying right here to go to the hundredth. Very explosive sneeze. If I go 0.4 and do the square root, then guess what it is? 0.63. That's unfair. We also did it correctly. Thank you very much. Okay, here's practice question number 1. This is at the end of the test. So just write your answer at the end of the test, at the end of the lesson. So just go ahead and write your answer down and then you can fill it in later. It says Leah asked 5 of her friends how many sports they play. She received the following responses: 1, 1, 2, 3, and 3. Calculate the standard deviation of the data. Round the answer to the nearest whole number. Pause the video, figure it out, come back. First step is to find the mean, which is the x with the line over it. So we do that by adding all of our points together. Hello, Holga, you don't need to be in my face. 1 plus 1 plus 2 plus 3 plus 3 gives us 10 divided by 5 points. Oh my gosh, stop. Will give us a mean of 2. So now we need to start making our table. We have 1 shink, 1 shink, 2 shink, 3 shink, 3. Now we need to find the difference between the point and the mean. So 1 minus 2 is negative 1, negative 1. 2 minus 2 is 0. 3 minus 2 is positive 1 and positive 1. Now we're going to square these values to get rid of the negatives. So we have positive 1, 0, positive 1, and positive 1. Now we're going to find the mean again. So 1, 2, 3, 4 divided by n minus 1, which is 5 minus 4. Oh, sorry, n minus 1, which is 4. So it ends up being 4 divided by 4, which is 1, which means that we need to then take the square root of 1, and that's a calculator thing because it's going to be some stupid number. The square root of 1, oh, it's just 1. I'm a genius. Okay, there's your answer. Here's practice question number 2. Calculate the standard deviation of the data set. Round the answer to the nearest hundredth. Pause it, figure it out, come back. Okay, so first I'm going to start by making our table. We have 1, negative 3. We have negative 2 twice. Negative 2, negative 2. We have negative 1 3 times. Negative 1, negative 1, negative 1. We have 0 twice. 0, 0. And we have 1 once. Ooh, I just barely fit that. Chonk. Chonk. Sound effects make everything better. Chonk. In fact, my line was straighter when I didn't make sound effects. But still, we're going to go chonk. Chonk. Okay. First thing we need to do is find the difference between the point and the mean. Oh, guess what? We don't have the mean, so I guess I should find the mean first. That might help a little bit. So we're going to take all of our points and add them together. And that gives us negative 3 plus negative 3 plus negative... Oh my gosh, you guys, what am I doing? Help me, help me. Negative 3 plus negative 2 plus negative 2 plus negative 1 plus negative 1 plus negative 1 plus 1 gives us negative 9. divided by 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's just going to give us a mean of -1. I think it has to just be a positive number, doesn't it? I've never had a negative mean before. I don't know. Let's continue. Let's find the difference. If the mean is -1, -3 minus -1 gives us -4. -2 minus -1 gives us -3. This will also be -3. -1 minus -1 gives us -2. -2. -2. Okay. 0 minus -1 is -1. -1 and 1 minus -1 is 0. Clear over here. Okay. Now, if my answer goes wrong, it's because this was supposed to be a +1 and I'm an idiot, but I really think this is right. Don't trust me. I'm not a math person. Let's square all of these. 4 times 4 is 16, and 9, 4, 1, 1, and this is 0. Now we need to add all these together and find another mean. So we have 16 plus 9 plus 9 plus 4 plus 4 plus 4 plus 1 plus 1 gives us 48. And it's going to be 48 divided by n minus 1. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 minus 1. So it's going to be 48 divided by 8, which I should know, but I don't do math. So that's going to be 6. So now we need the square root of 6 because that's our last step. Let's figure that out. That's 2.45. 2.45. That should be your answer. If it's not, this doesn't get graded, so you can forgive me. All right, here's quick check question number 1. I will not give you these answers, but I will tell you how to solve the problem. There's somebody at my house, so I gotta pause this. Let's continue. This math lesson has been interrupted so many times I can't even tell you. So I won't give you the answer to these questions, but I will tell you how to solve the answer because this one you get graded on. So calculate the standard deviation of the data set, round the answer to the nearest hundredth. So if the dot plot helps you, what's going to happen is you have the value 4, you have the value 5, and you have the value 6, and this is how many times they occur. There's only 1 dot for 4. There's 3 dots for 5, and there's 1 dot for 6. So you're going to make a table chart with how many times these appear, okay? Then you're going to find the mean, okay, which will be your X bar answer, okay? Then you're going to find the difference between the point value, subtract the X bar answer. Then you're going to take that and you're going to square that and make a new line in your table. Then you're going to take that number and find the mean again, okay? And then you're going to take that number and divide it by n minus 1. Then you're going to take that number and do the square root. This is what we've been doing the whole time, and it'll be one of these answers. If you need more help, comment, and I will make a more detailed video. Here's quick check question number 2. Charles records the number of miles he walks every day. The chart includes how many days he walked. The given number of miles for 1 week. Calculate the standard deviation for the number of miles he walked. Round the answer to the nearest hundredth. So again, if the dot plot helps you, you're going to have value 3, value 4, and value 5. And then 3 occurred twice, 4 occurred 3 times, and 5 occurred twice. Go ahead and do all of your steps. Standard deviation is the most appropriate measure of variability when using a population sample in which the mean is the best measure of center and the data distribution is normal. It's often used to show the average spread of data when deciding if the number is within normal variation or spread. Average deviation is a better gauge of variability when there are distant outliers or the data is not well distributed. Yippee! Here's example number 1. Try to sort the following 3 data sets and their standard deviations to list them from least variation spread to largest variation spread. Use the worked example to check your answer. So we're going from least, oh my goodness, to largest. Okay, we're starting least spread, so most contained, most closest together to the biggest spread. Here's the secret. You just want the smallest number, so here's number 1, number 2, Number 3. It's that easy. This shows the most spread, the most variability. This is the least variability, okay? This goes into, it makes this a lot more complicated than it has to be, okay? So the least variation is C, which we have. The next one would be A, which we have, and the last one would be B, okay? Here's a check-in, true or false. If one data set has a higher standard deviation than another data set, then the data in the first set is more spread out. So number 1 has a bigger number. Number 2 has a smaller number. Then is the data in the first set more spread out? True or false? That's true. Bigger number, bigger spread. Example number 2, calculate the standard deviation of the following data set. Round to the nearest tenth. Explain what it is telling you about the data set. Okay, so we're going to do all of our steps again to figure out the standard deviation, and then we're going to say what it's telling us. Okay, so the first thing we need to do is find the mean, which is the x with the line over it. So let's go ahead and add our values together. We have 3 plus 4 plus 5 plus 5 plus 6 plus 7. And we're going to divide, that gives us 30. 1, 2, 3, 4, 5, 6 divided by 6 gives us 5. So our mean is 5. If we make our little chart, we have 3, 4, 5, 5, 6, that's very straight, 7. I wrote these numbers up here so crooked. Okay, so 5 minus 3 gives us 2. Nope, sorry, 3 minus 5. I can do this. I can do this. I can. 3 minus 5 is negative 2. 4 minus 5 is negative 1. 5 minus 5 is 0, 0. 6 minus 5 is 1. 7 minus 5 is 2. We need to get rid of the negatives. So now we're going to square them. So we have 4, 1, 0, 0, 1, 4. Now we need to find the mean again for these numbers. So 4, 5, 6, 7, 8, 9, 10. So that's going to be 10 divided by n minus 1, which is going to be 1, 2, 3, 4, 5, 6, 5. So that's going to give us 2. And then we need to take the square root of 2, which we've done before. But do I remember that number? No, because why would I care? And we want it to the nearest tenth, so it's 1.4. And what that tells us is that if we have our little dot plot and we have our mean of 5, most of the data points are going to fall within 1.4 data places of this. So 1.4 this way, so 6.4 over here. And gosh, that requires 3.6 this way. Okay, most of your data points are going to fall within this range. Okay, that's all that's saying. So here's all the steps. La 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 la. La 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 la. Here is another check-in. What does standard deviation measure and how is it calculated? Standard deviation measures how spread out a set of data is from the mean. It is calculated by averaging the squared differences between each data point and the mean. Here's question number 1. This is your turn. Given the following 2 standard deviations, which data set has a greater spread? Remember, bigger spread means bigger number. So it's going to be this one. Okay. Given the following 2 data sets, find and interpret the standard deviation of each. So for this one, we have to do all of the steps again. First, we need to find the mean for each of these. So here's the mean for data set A. Let's figure it out. 2 plus 2 plus 5 plus 6 plus 9 plus 10 plus 11 plus 14 plus 15 plus 18 plus 18 gives us 110. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 110 divided by 11 gives us just plain 10. So the mean for our first one is 10. Let me change my color, my pen color, and we're going to go 2, 2, shink, shink, 5, shink. These diamonds are distracting. 6, 9, 10, 11, And then it goes on and on and on and on. Okay. So you're going to find the difference between this and the mean. So 2 minus 10 is -8, -8. 5 minus 10 is -5. 6 minus 10 is -4. 9 minus 10 is -1. 0, +1. Okay. You would do that for all the numbers. I ran out of room. Square it. This becomes +64, +64, +25, +16, +1, 0, 1. Then you're going to find the mean, so you'd add all of these together and divide by n minus 1. And then you take that number and find the square root. And in the end, you do that for both of them. In the end, the standard deviation of set A is 5.83, and for set B, it's 5.40. This one has the bigger number, so it's got the bigger spread. And this one has a smaller number, so it's more consistent and not as spread out. Here is practice question number 3. Which data set has the highest variability? Speed round. Boo, 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 boo. The biggest number, biggest variability. There you go, right there. The only thing that matters is the standard deviation, okay? This is just extra garbage. All right. Totally answered this question for you and had to erase stuff and go back and do it again. So compare and interpret the measures. Select the data with the least variation. Guess what? This is the only thing that matters. So find the least variation, find the correct answer. Here is example 1. Compare the variability of the following data sets round to the nearest hundredth. Guess what? This is all just more of the same garbage. So first you're going to find the mean, which is the x with the line over it for each of these. And then you're going to find the difference, which is there. And then you're going to square it to get rid of the negatives, which is there. And then you're going to take all of these, add them together, and divide it by n minus 1, which is going to give you that. And then you're going to take that and find the square root of it. And now you know that the standard deviation for this is 1.58. Now you're going to do all the same garbage for data set B. So first you find the mean. Okay, then you take that mean and you figure out the difference between the data point and the means, which is that. Then we're going to square all of this information to get rid of the negatives, which is that. Then you're going to add all these together, divide it by n minus 1, which gives you that. Then you're going to take that and find the square root of it, which is that. And in the end, you find out that the standard deviation of data set A, which is 1.58, is smaller than that of data set B. So data set B has more variability. Okay. If you need more help on this, comment, and I will go and work through these, but this is all just the same stuff. I feel like it's just way too repetitive to waste your time. Here's a check-in. What is the purpose of comparing the standard deviations of 2 or more data sets? The purpose of comparing standard deviations is to observe the changes in variation which can show trends in data. Try to compare the data sets on your own before going through the worked example round to the nearest hundredth. So try to solve this on your own. Pause it. Go through all the steps. Come back and see if you are right. First thing you're going to do is find the mean for each of these, okay? Then you're going to find the difference between the data point and the mean. Then you're going to take your difference and square it. Then you're going to take these squares, add them together, and divide them by n minus 1, right? And then you're going to take that number, and you're going to find the square root of it. So that's your standard deviation for data set 2. Now do the same thing for data set B. Sorry, data set A. I'm tired. Okay, so first find your mean. Then find the difference between your data points and your mean. Then the next step is to square those so that you can get rid of the negatives. Then you're going to add all these together and divide by n minus 1. Then you're going to take that number and find the square root of it. And then you have both of your standard deviations, okay? And you can see that the standard deviation of data set A, which is 2, is greater than the standard deviation of data set B. So data set A has more variability. Data set A is more spread out, okay? What does it mean if 2 graphs have the same standard deviation? If 2 graphs had the same standard deviation, that would mean that they have the same variability spread of the data points. Okay, this is at one of the questions at the end. Question number 1, a company wants to compare the variability of the salaries of its employees in 2 different departments. The company has the following data. Department A has a mean salary of $100,000 and a standard deviation of $20,000. and Department B has a mean salary of 100,000 and a standard deviation of 10,000. How can you compare the variability of the data, and what conclusion can you draw from it? Pause it, figure it out, come back. So these have the same mean salary, so the only thing that matters are the standard deviations. And what these tell you is that in Department A, there's a bigger variation, there's a bigger spread in wages than there is in Department B. Okay, that's all it says. Here's question number 2. A toy company produces 2 different types of toys, toy A and toy B. The company needs to compare the variability in the production quality of the 2 toy types to determine which one has a more consistent output. They collect data on the number of defective toys produced each day for both toy types over a span of 10 business days. The data is summarized in the table. Compare the variability in the production quality of the 2 models by calculating the standard deviation for each data set. Explain how the company can use the data. So pause the video, figure it out, come back. So first you need to find the mean for each of these. Then you're going to find the difference between the point and the mean. Then you're going to square that difference. And then you're going to find the mean for that. And then you're going to divide it by n minus 1. And then you're going to find the square root of that for each toy A and toy B. And that will give you the 2 standard deviations. And what you find is that toy A has a standard deviation of 1.2 and that toy B has a standard deviation of 2.11. Okay, these means are the center point on your dot plot where they balance at. Okay, that's all that the means are. They don't really matter for these questions. Toy A has less variability, so it's more consistent. That toy A is a more consistent production quality. They have less mistakes and like already broken toys that come out from the machine. And this can help the company make more informed decisions regarding quality control measures to enhance the overall reliability and consistency of the manufacturing process. Good for them. Here's practice question number 4. Find the standard deviation of the data set rounded to the nearest hundredth. Pause it, figure it out, come back. First we need to figure out the mean. Okay. We do that by taking all these data points, adding them together. 15 plus 18 plus 11 plus 17 plus 14 divided by 5. 75 divided by 5 gives us 15. Okay, so now we have 15 minus 15 gives us 0. 11 minus 15 gives us negative 4. Now we're going to square all of these. Negative 4 squared becomes positive 16. Okay, now we need to find the mean for this stuff. So we have 0 plus 9 plus 16 plus 4 plus 1 is 30 divided by n minus 1, which is 5 minus 1. So that becomes 30 divided by 4, which gives us 7.5, and then we need to take the square root of that. And we want it to the nearest hundredth, so it's 2.74 for your final answer. Here's practice question number 5. Find the standard deviation to the nearest hundredths and then compare the variability of the data sets. Enter the number of the correct option. Okay, we have 2 data sets. Pause it, figure it out, come back. Let's start with data set A. We're going to find the mean first. We're going to go 10 plus 8 plus 10 plus 8 plus 8 plus 5 gives us 49 divided by 6. Because that's how many data points we have, is going to give us 8. Now, I'm guessing that they're stopping here because that's what they did on the one problem, but I can't guarantee it because this book is stupid. So let's go 10, 8, 10, 8, 8, 5, and we need to find the difference between these numbers and the mean. 10 minus 8.2. Oh my gosh, you're going to make my life hard. 0.8 would take it up to 9, so 1.8. And then 8 minus 8.2 is negative 0.2. 10 minus 8.2, that's another 1.8. That's another negative 0.2. Negative 0.2. 5 minus 8.2 is a negative 3.2. Okay, now we need to find the squares of all these. Calculator time. Come on, pretty boy. 1.8 times 1.8 gives us 3.24. 24. Let's put it here too. 3.24. Negative 0.2 should be negative 0.4, but I don't trust myself. So 0.2 times 0.2 gives 0.04. See, it's a good thing that I did that. 0.04. 0.04. 0.04. And now let's do 3.2. Clear. 3.2 times 3.2 gives us 10.24. Now let's find the mean of all this garbage. So we have 3.2, fat finger, 24 plus 0.04 plus 3.24 plus 0.04 plus 0.04 plus 10.24 gives us 16.84 divided by n minus 1. So 1, 2, 3, 4, 5. 16.84 divided by 5 gives us 3.368. And then we need to take the square root of that. And we're rounding this to what? It doesn't tell us. Hundredths. So this one is going to be 1.84. Okay, so let's work smarter, not harder, and go through here. Data set A should be 1.84. So data set A, that one works. Can't be number 2. Go away. Go away. Could be that one. So let's see. I did the same for data set B. Data set B is both 1.79, so I'm not going to bother solving it. And what this means is data set A is larger. That's correct. The standard deviation of data set B is larger. That doesn't make sense because data set B is a smaller number, so it has to be this one. Work smarter, not harder. Quick check question number 4. If the mean of a data set is 59, what is the deviation of the data point at 43? Don't make this harder than it has to be. What that means is that the x bar is equal to 59. And if we have our little table clear full of data points, it just wants to know right here at number 43, what is x minus the x, the mean of x. That's all it wants to know. So solve that and put in your answer. Quick check question number 5. Use the standard deviation to compare the variability of the data sets. Round to the nearest hundredth. You're going to do the exact same thing that we did for the practice question. So first find your mean, and then you're going to make your little table and find your point minus mean. And then you're going to square it. And then you're going to take that number and you're going to add them together and divide by n minus 1. And then you're going to take that number and you're going to find the square root. And hopefully it will be easy enough that you'll be able to eliminate enough options and find the right answer again. If not, do all the same things for data set B. And just so you know, everything goes back to Stray Kids because, you know, I sat here and this Canva presentation came with jewelry and I was like, Stray Kids has a bunch of jewelry deals.